we're solving right triangles. The first thing you have to understand is how to solve something like this. Normally, we've given you the angle measurements. Now we have to actually calculate the angle measurement. Does anybody remember how to do that? Yeah, how do we get x by itself? You'd like to think that, but it's not quite the right. It's the quite.
No, not the inverse.
Yeah. It's the inverse. So when you're solving equations, like if I had x plus 3 equals 8, I subtract that, right? In this context, these are actually called inverses. We've changed our language at the school to reflect that, the vocabulary. Those are actually inverses. Multiply and divide are inverses. Square, square root, inverses. Okay, so it's the same concept. You're using the inverse, okay, to solve the problem. What's the sine inverse of root 3 over 2? Does anybody remember their unit circle? The y value, because it's sine, the y value at 60 degrees. Or you can just look at the table at the beginning of 5.5. That's the answer. I guess I'll write it on here. I mean, for the old school. Oop. If that's the coordinates of a point where sine is root 3 over 2, what's the measurement of that angle in the unit circle? Okay, so one way is to know the unit circle. Okay, the other way is to look at 5.5 page. What page is that, lady? 305. Page 305. Okay, there's a root. Are you guys okay? Do I need to go regulate? You're taking. Not in my weekend state. So look at the table. If you find root 3 over 2 and 60 degrees, so the angle is 60 degrees. Okay. What's the cosine? What's the angle when the cosine is 1/2? Same deal. Okay, so cosine 60, sine 60. Right. That's another reason, the unit circle is pretty useful if you know how to use it. Okay. There's a little mouse in my classroom. Anybody? Easier than you think it is.
Are we just trying to find the tangent? Would it be why?
Because they're inverses. So this is basically like saying that. It's not stupid, it's cool. It's one of the neat things about math that you guys can have the relationship from like when you were in 5th grade when you started solving equations all the way up to calculus.
Yeah, I like the fact that it was fun. I was good at it. Like
So inverses take care of each other, right? Let me actually get the right one. Okay, so now we can throw you a little bit harder problem where they can't cancel each other out, quote unquote, cancel each other out. You prefer a decimal answer? I prefer a fraction answer, so I'll show you both.
So the answer to the first one was just.
Yeah. No. The inverse of sine is sine inverse. Sine and sine inverse are inverse functions. Okay, don't confuse yourself. Okay. In your calculators, okay, second sine 2/3. Yeah, second sine 2/3. Like 57 something.
41.
Oh, okay, I'm way off. Okay, what's cosine of 41? Okay, okay, so okay, there's the decimal answer.
Yeah, I got 5-4, not 4-5.
I got 4 or 5.
Did you? How many decimal places did you go to?
I'm 7-5-4-7.
If you do 41, it's going to be a little bit different than if you do 41 point whatever. Okay, here's the, so that's method 1. Method 2 is the fraction. Now, this is the make your math teacher happy way. You want bonus points. Okay, sine is
Yeah, will we seriously get bonus points?
probably not. This is my, okay, sine's opposite over hypotenuse, correct? So 2/3. 2 is the opposite. 3 is the hypotenuse. What's the adjacent side? Because we're going to go with cosine, we need the adjacent side. It is the square root of 5. So use the Pythagorean theorem as we've been practicing. No decimals. Yeah, I'm no fun. Okay, so we get root 5 for A. Use the Pythagorean theorem. What is cosine? Nope.
No, it's opposite.
Those are the same answer. The decimal answer is a cop out. The fraction answer makes your math teacher happy. Haha, funny, funny. Yes, you guys can laugh. You guys need to live a little. You guys need to live a little. Yeah, I mean, what do you do when you stay up till 2 in the morning? One of you. No, I know the answer to that question. You don't have to say it.
She would honestly do it.
Okay, what's the value of alpha? We have just a couple more things and then we're done. So we've been solving for legs. Now we're solving for angles. How do I calculate alpha? Yep. Cosine alpha. Hey. Alpha is just a letter.
Why are you making fun of alpha?
Okay, I don't want to dump the entire Greek alphabet on you next year. I have to introduce it to you this year.
But I don't understand the point of it at all.
It's like, it's just a variable.
It's just like
It's like, you could put a bubble in there and say cosine bubble. And what's the value of the bubble? It doesn't matter. It's just an arbitrary it's just an arbitrary representation of some numerical value that we do not know. Yes, it makes you angry. Just wait until you get to like lambda.
We already talked about how to solve that. It looks kind of like a dinosaur though.
We could also do beta. Here's capital Omega. You know, like the watch company, that's their logo.
What is that letter? What does that letter translate into?
O.
That's beta B.
Alpha, beta. I don't remember the rest of them. I used to know. Okay. Because we need more. When you get, so here's the point of using the Greek alphabet. In English, we use all the English letters to represent something specific in math all the time. So when you get to upper levels, calculus and above, these letters actually take on specific meanings and roles. Okay, so that lambda that I told you, there's only one spot in calculus that's used. It's a very specific place for it. So we have to have more symbols to represent values. Okay, so we bring in the Greek alphabet. And the Greeks had a, minor role in developing mathematics. Yeah. Okay, so what's the measurement of that angle?
Yeah.
57? That's where I got my 57.
What is the calculator do?
That's the angle measurement. 57.9 degrees.
How does the calculator happen?
It has a table of values in its memory. It knows the ratio to 4 decimal places. So the calculator has a table in itself. 4 decimal places, the ratio of every possible adjacent to hypotenuse. And it's paired up with a cosine value. So all it does is references that decimal, which is this, and spits out the angle measurement. Every single old trigonometry book has that table in it. When I was in high school, it had that table in it. I don't think yours does. Okay. I can show it to you later, but we know the trig ratios. That's all they represent. If this is 17 to 32, it has to be a specific angle. That's what cosine tells us. It's just a function to represent that. How could we calculate the opposite? Whoa. Yes, sine works. Or you can use Pythagorean theorem. Okay, so I'm not going to go through it with you because I've shown you how to do those already. So lots of options there. What about beta? Yeah, I did that just for you. Don't look at me like that. You're being snarky.
I know exactly why you said that too.
There was no deeper meaning to that.
You get a nerd.
I'm sorry.
We're all friends with
Oh, okay, well, I didn't know. Open mouth, insert foot.
people in law history that use the name.
What's the easy way to solve for beta? Yeah.
Because 180 is all the angles.
Remember, triangle, all the angles add up to 180. So 180 minus 90 minus 59.7. That would be a condition of employment, yes. Well, same triangle. Or you could use sine or tangent. I mean, take your pick. Do you think you can handle these?
Yeah.
That's called solving a right triangle. Okay, so you might see the vocab solve the right triangle. It means find everything there that's missing. Okay. Yes, you have to use sine, cosine, and tangent. You use whatever the book says to use.
Come on, man. You can do that.
That's what I know. I was like, really?
I can add more if you'd like,
No.
because that is a short assignment. It really is.
And you are a short person.
I see what you did there. We're no longer friends. I know. I was just throwing it back on her because I never agreed with her. I really am trying to minimize your work because I know you're busy. I know you're working a lot. I'm minimizing it. Okay? So please be grateful and don't complain when I actually give you homework.